Hello, so welcome back. Today we're going to look at a predicted paper 2 higher tier for the upcoming GCSE exam, which I think is on June the 8th. So this is a calculator paper. We're going to just have a crack at it. But as always, let's just have a sneaky peek at the page to start with. So we've got an hour and a half, blah, blah, blah. We want to be using our calculator as much as possible. And then we've got this formula sheet, haven't we? So a bit of perimeter, area and volume, all that kind of stuff. We've got the quadratic formula, we've got Pythagoras theorem, and we've also got the sine, cosine rule, the area of a triangle, and trigonometry and all that jazz. Compound interest, and then some probability stuff. So let's keep that in mind, and I've got my trusty calculator that I'll use as much as I can. Alright then, so let's get cracking. So number 1, it says describe fully the single transformation that maps triangle A onto triangle B. Okay, so there's a few bits of information they're going to want from this. The first one is what kind of transformation is it? So let me just start off by writing them all down. So there's 4 options. It'll either be a translation, which is just where it doesn't change but it's moved somewhere. The next one is a reflection, so where it's been flipped over some line. Then it's enlargement, where it's got bigger or smaller, and then finally a rotation, where it's been turned around. Now this to me looks like it's got bigger, so this is an enlargement. So I'm going to start off by saying that A has been enlarged. So that's one piece of information. The other thing they need to know is, well, how much bigger or smaller is it? Well, if we just have a little look, so this side of the triangle of A is 3 across, and if we match the same side onto B, that is 6 across. So that looks to me like it's been doubled. You might just want to check with some other sides, but pretty sure. So this is 2, and that's 4. Yes, so it looks like it's been doubled. So my second piece of information then is it's been enlarged by a scale factor 2, so because it's been doubled, and then they'll want you to show the centre of it. Now the easiest way to do this is to join up the matching vertices, keep them going forever, and you'll see all those lines for each vertex cross at one point. So I don't actually have a ruler with me, but for example you would join these 2 lines up, oops, and then if it'll let me, and then and then just keep going like that. Then you join these 2 lines up, keep going, and then you join these 2 lines up and keep going. Now obviously that's not very accurate because I've not done it very well, but maybe it's going to be here somewhere. If you've not got a ruler, another way of doing it is to look at how you get from one point to the other. So let's pick a point on our triangle, that one, and then the matching one is here. And let's think about how it's got there. Well, it's moved 1, 2, 3, 4 down, and it's moved 1, 2 across. Now this is a scale factor of 2, so to get to our centre, we're going to want to do the same again, another one. So this is going to be 1, 2, 3, 4 down, and 1, 2 across. So I'm thinking that that is our centre there. Okay, and then if I just again, if I had a ruler, this would be a lot easier. But again, if I just kind of try and join up, yeah, it's not too bad. It looks like that's the centre of projection. Okay, so scale factor of 2 and then centre. So the coordinates of that look to be 6 and -7. Okay, great. Alright, so number 2, so a number is rounded to 2 decimal places and the result is 0.18. Write down the error interval for x. Okay, well, so if we're on 0.18, it's been rounded to 2 decimal places. So the way that I like to think of this is I like to put it on a number line and think, well, what was the previous number and what was the next number? So if we're thinking about 2 decimal places, the previous number would have been 0.17. and the next number would have been 0.19. And then to find the error interval, you then just look at the middle bits of those numbers. So between 0.17 and 0.18 is going to be 0.175, and between 0.18 and 0.19 is going to be 0.185, and that is going to be my error interval. Now notice we've got an equals bit here, so this is less than or equals to, and that's because if it was 0.175 you'd round it up, wouldn't you, to 0.18. But notice for this bit there's just the less than sign, and that's because if it was 0.185 it would round up to 0.19, so it wouldn't go back down to 0.18. Alright, so that's why it could be equals 0.175, but it can't be equal to 0.185. Okay. Alright, next question. So 3a says simplify a to the 9 times a to the 4. Well, when you times the same thing together, you add the powers up. So this is just going to be a to the power of 9 plus 4, which is 13. Second one, we've got 4b to the b to the 2, yeah, b squared times c, and it's all to the power of 3. Well, we can just do all these separately. So this is the same as saying 4 to the 3 times b squared to the 3 times c to the 3. Okay, well 4 cubed, again, no need to work it out, stick it in your calculator. 4 cubed is 64. Now, a power of a power, you times them together. So 2 times 3 is 6, so this is b to the 6, and then that's just c cubed. And then finally, d to the 9 divided by d to the 4. Well, when you divide, you minus the powers. So this is d to the power of 9 minus 4, which is 5. And that's that question. Alright, number 4. So given that a to c is 1 to 6 and b to c is 2 to 5, we want to find the ratio a, b, c. Give your answer in its simplest form. Okay. Well, the first thing I'm noticing is that there is a c in both of our ratios, and that is 6 and 5. So my first goal is to match them up if I can. So the best way to do this is to find a least common multiple, and we can just times these together. 5 times 6 is 30. So now we've got, let's just write these down again. So a to c is 1 to 6, and b to c is 2 to 5. But we want to convert these so that our c is 30 for both. Okay, now what has happened here? Well, this 6 has been times by 5, so we want to times 1 by 5 as well, so that's going to be 5 to 30, like that. And then what's happened to this one? Well, this has been times by 6, and so we'll want to times 2 by 6 to get 12. Okay, and then a to b to c is just going to be 5 to 12 to 30, and that can't be simplified, mainly because 5 is prime. Okay. Okay, so number 5, Nick bought a new car. Each year the car depreciates in value by 12%. Work out the number of years it takes for the car to halve in value. Alright, so if it depreciates, that means it's going down. So if we think 100% is what it originally costs, and we are going down by 12%, that's going to leave us 88%, or we can write that as 0.88. So we want to work out how many years it will take for the car to halve in value. Well, half is 50%, or 0.5, and the way we're going to work out how many years it takes is by doing powers of this 88%, because 88 is going to be a percent, and it's going to take 88% each year of whatever's left. So if we start off then with, so year 1, so let's just write year 1, it's going to be 0.88 to the power of 1, which is just 0.88. Year 2 is going to be 0.88 to the power of 2. So again, let's just use our calculator. 0.88 to the power of 2, and that is going to be 0.7744. And we just keep going. So if we do it cubed, we're going to get 0.681472. Year 4, 0.88 to the 4. That's going to be 0.599695336. So we're getting closer and closer to 0.5. 5 is going to be 0.88 to the 5, which is 0.52773191168. And I'm hoping this next one will be under 50%. And yeah, that's 0.4644040868. So it's going to take 6 years to get to less than half of the original price. Alright then, question 6. So we've got in London, potatoes cost £0.45 per pound, and in Dublin, potatoes cost €1.48 per kilogram. We've got a couple of conversions here. So we've got 1 kilogram is £2.2, and we've got that £1 is worth €1.15. So in which city are potatoes better value for money, in London or in Dublin? So we just need to convert one to the other, so why not convert Dublin to London? So in Dublin, I'll just get my pen, there we go. So in Dublin, we've got that it is €1.48 per kilogram. But we know that 1 kilogram is 2.2 pounds, so we can write that as per 2.2 pounds, like that. And then to make that to £1, we just want to divide by 2.2. So 1.48 divided by 2.2. Again, I'll just use my calculator. That's going to give me 0.672, where the 72 is recurring. And then we want to turn that into pounds, and the exchange rate is 1 to 115, so we're going back to pounds. We want to divide by 1.15. So 0.672 divided by 1.15, and that gives me 0.58 to the nearest penny. Yeah, so let's write that. Okay, so for a pound then it's a lot more expensive in Dublin. So potatoes are therefore better value for money in London, because here it's £0.58. Let's just write the units, and that's per pound, which is obviously more expensive. Okay, so number 7. So the diagram shows a patio in the shape of a rectangle. Lovely. Jack wants to cover the patio with paving slabs. Each paving slab is a square of side 40 centimetres. The paving slabs cost £7.59 each, and Jack has £300 to spend on paving slabs. Does he have enough money? Alright, so a couple of things. So first thing is we've got these measurements here, and they're in metres, and our paving slab is in centimetres. So the first thing I want to do is convert 40 centimetres. Well, that's the same as 0.4 metres. Okay, so now if we think about how many slabs we're going to need, well, if this is 1.6, we need to think about, well, how many 0.4s is that? So 1.6 divided by 0.4 is 4. So we know that we're going to need 4 slabs per column, if that makes sense. And then similarly over here, 3.6 divided by 0.4 is 9. So I won't do this all, but the idea is we'll get 9 slabs across and 4 slabs down. So total number of slabs is going to be 9 times 4, which is 36. And then we want to work out how much they cost. Well, that's just going to be, so total cost is going to be 36 times £7.59. And that gives me £273.24. So Jack does have enough money. Yeah, because he's got £300 and he only needs £273.24. We're doing alright so far, I think. So number 8, use your calculator to work out the square root of tan 80 plus 1 over tan 80 minus 1. Write down all the figures on your calculator display. Alright then, so it's just going to start off with my square root, then I'm going to press the fraction symbol, and then it's going to be tan of 80 plus 1. Make sure my 80 is separate to the 1, and then over tan of 80 minus 1, press enter, and the answer I'm getting, we want to write down all the figures, so that's going to be 1.195051466. And then want to write my answer to part A to 3 significant figures. So we look at our 3 significant figures, we've got 1, 2 and 3, put a line after it, and then see if we round up. Well, because this next number is a 5, I'm going to be rounding up, so this is going to be 1.20. Okay. Number 9, so Lucy is 3 times as old as Alex, and Lucy is 7 years older than Megan. The sum of their ages is 126. Find the ratio of Alex's age to Lucy's age to Megan's age. Alright then, well if we start off with Alex, so we've got Alex, Lucy and Megan. So the best way to do this is to use some algebra. So Lucy is 3 times as old as Alex. So let's say that Alex is X, whatever that might be. Call it X, call it Y, Z, B, Jeff, whatever you want to call it. It doesn't matter, but it's X. And then Lucy's going to be 3 times as old as that. So Lucy's going to be 3X. And then Lucy is 7 years older than Megan. Well, that means that Megan is 7 years younger than Lucy. So Megan is going to be 3X, which is Lucy, but she's 7 years younger, so it's going to be minus 7. Then it says the sum of their ages is 126. So all these things added up are going to be 126. So we've got X for Alex plus 3X for Lucy plus 3X minus 7 for Megan, and that's going to be 126. So let's just tidy this up a bit. How many X's have we got? Well, we've got 1 here, plus 3, plus another 3, so altogether that is 7X. Everything else stays the same. And then we want to solve it. So the first thing we want to do, because there's a minus 7 here, we want to add 7 to both sides. So 7X is going to be 133. And then, because we've got X times 7, we want to divide by 7. And again, just use your calculator for this. So 133 divided by 7 is 19. So I shouldn't put equals there. I should just write X is 19. Okay. So finally, we want the ratio then. So let's just use this 19 to figure out everyone's age. Well, Alex is X, so that's 19. Lucy is 3X, which is going to be 3 times that, which is 57. And then Megan is 3X minus 7, so take away 7 from that and we get 50. So the ratio then, Alex to Lucy to Megan, is going to be 19 to 57 to 50. And that's our answer. Okay. Okay, number 10. Find the equation of the line parallel to 2x plus 5y equals 10, which passes through 0 minus 3. Okay, well the first thing is, this is a straight line, but it's not in our form that we like. So every straight line can be written in the form y equals mx plus c, where this is the gradient, so this tells you how steep the line is, and this tells you the y-intercept, so where it crosses the y-axis. So we just want to rearrange this to make it look like that. So that's our first goal. So we've got 2x plus 5y equals 10. So the first thing I want to do is take away that 2x. So we'll take away 2x from both sides. So this is going to be 5y equals minus 2x plus 10. And then to get y on its own, I just want to divide by 5, and that's everything divided by 5. So that's going to give you y equals minus 2 over 5, because I'm dividing by 5, x, plus, and 10 divided by 5 is 2. Okay, lovely. So that is our equation in our nice formula. We've got the gradient and the intercept. Now, if this is parallel, parallel means that the gradient is exactly the same. So in our parallel line, it's going to be y equals same gradient minus 2 over 5x. And what's the y-intercept? Well, actually, they've given you a very nice thing here, because when x is 0, that is the y-intercept. So when x is 0, y is minus 3. So this is just going to be minus 3. And that is our answer there. Okay. Okay, number 11. So Carlos wants to find an estimate for the number of ants in a colony. He catches 60 ants from the colony and marks each one with a die. He then returns the ants to the colony. Okay. So a week later, Carlos catches another 60 ants. 8 of these ants are marked with a die. Okay, work out an estimate for the number of ants in the colony. Okay, so let's think about the first situation then. So we don't know how many ants there are. That's what we're guessing. So we are going to put out of x. So x is the guesstimate, the guess for the number of ants in the colony, and he has marked 60 of them. Okay. Then he catches another 60 ants, and out of those, 8 of them are marked with a die. So 8 out of 60 are marked with a die. Okay, so let me just get rid of this equal sign. So what we're looking at now is how do we get from 8 to 60, and then that's going to match up with how we get from 60 to x. So we just see 60 divided by 8. So let's just write that down. So 60 divided by 8 is 7.5. So to get from 8 to 60, you would times 7.5. And so to get our estimate for the x, we're going to do 60 times 7.5. And 60 times 7.5, again, just use my calculator. That gives me 450. And that is my guess for the number of ants in the colony. Okay. Carlos assumes that none of the marks had rubbed off. If Carlos's assumption is wrong, explain what effect this would have on your answer to part A. Okay, well, if he's wrong, you know, this number here should be bigger, shouldn't it? You know, if some of the numbers have come off, then that means more of these ants might have been the ones that he caught originally, but the marks have just rubbed off. So that would mean that this times number would be smaller, yeah, because you have to times it by a smaller number to get to 60. So the answer would actually be smaller. So this would make the answer smaller as the fraction of marked ants would be bigger. Oops. Okay. Okay, so number 12. So the table shows some information about times in minutes it took some boys to complete a puzzle. Alright, so it's taken, well, some lads taken 29 minutes to finish this puzzle, so hopefully it wasn't too difficult. So we want to draw a box plot for this information. So for a box plot, we need 5 bits of information. We need a minimum, we need a maximum, we need a median, we need a lower quartile, which we've not got, and we need an upper quartile. Okay, so the only thing we've not got is a lower quartile, and the thing that's going to help us with this, if I just use a slightly different colour, is the interquartile range. So the interquartile range tells you what's the distance between the upper quartile and the lower quartile. So if our upper quartile is 23 and our interquartile range is 8, then our lower quartile is going to be 23 minus 8, which is 15. Okay, and now I can start drawing my box plot. Now the minimum and maximum are going to be our whiskers, so they're kind of the end points. So our minimum is 12, So if I look at the graph, there are 10 squares for 5 minutes. So there's going to be 2 squares for each minute. So 12 minutes then is going to be there. And 23 minutes is going to be, sorry, that's my upper quartile, sorry. So my maximum is 29, and that is going to be there like that. Lovely. So now I want to put in my lower quartile. So my lower quartile is 15, so that is there. And we always want our box to be slightly narrower than the whiskers. We've got our median is 18, and we've got our upper quartile is 23, like that. So I just want to join up my lines to make my box, and then connect the whiskers. And hey, that's not too bad without a ruler. Okay, so that is my box plot. Great. So now we've also got the distribution of the time it took some girls to complete the puzzle. Okay, so, and we want to compare the distribution. Now we're asked for 2 marks for this, so we want to pick up 2 points. And you can pick up anything. So, you know, you can say that the girls, well, I think everything of the girls is lower. They seem to have done a lot better with this puzzle. So the minimum is lower than the boys' minimum, the maximum is lower than the boys' maximum, so we can just put that. So the minimum for girls is lower than the minimum for boys. Yeah, and well, we could say the maximum is lower than the maximum for boys. That's perfectly fine, but we might pick something else. The other thing I've noticed is that the interquartile range for the girls is shorter. Yeah, so the box is a lot thinner than it is for boys, so I might put that. And just for something different, and the interquartile range for the girls, and if you want you can put in some numbers. So the interquartile range, that is 11 and that is 17, so it's an interquartile range of 6, is lower than for the boys, which was for 8. Okay, alright, so let's keep going. Okay, so number 13. So it takes 30 builders 12 days to complete a job, and we want to work out how many days it would take 40 builders to complete the same job. Okay, so we've got, so 30 builders, let's call it, is 12 days. So we want to see what 40 builders would do in terms of days. Now this is a bit of a proportion question, so you think what are 30 and 40 in the times table of? And they are in the 10 times table. So let's put 10 builders here. So what we've got to think here now, from 30 to 10, we divide by 3. But less builders is going to take more time. So for 12 days, we want to times by 3. So for 10 builders, it's going to take 36 days. And then from 10 to 40, we times by 4. But more builders is going to mean fewer days, so we want to divide by 4, and 36 divided by 4 is 9, so we think it will take 9 days. Write down any assumption that you've made. Well, I've made the assumption that all the builders are working at the same rate. Yeah. All the builders are working at the same rate. Yeah. Whereas in reality, there might be one lazy builder that's always smoking and having a bacon butty, and the others might be working harder. But in this scenario, I've assumed that they're all working the same. Okay, so number 14, a functions question. So we've got that fx is 2x minus 4, and g of x is 3x plus 5. And we want to find g of f of 3. So when you have a composite function or a combination of functions, you always do the one that's closest to the number first. So this is f of 3. So we're going to start off with f of 3, get an answer, and then do g of whatever the answer was. So let's start off with f of 3. And that means just shoving 3 into f. So f was 2x minus 4, so this is going to be 2, lots of 3 minus 4. 2 times 3 is 6, and 6 minus 4 is 2. So f of 3 is 2. And now we want g of f of 3, so that is going to be g of 2. So now we shove 2 into g, so that's going to be 3 times 2 plus 5. 3 times 2 is 6, plus 5 is 11. So g of f of 3 is 11. So next up, we've got work out an expression for f minus 1 of x. Well, I think the best way of doing this is to draw a little function machine for f of x. So if I put f into the machine, the first thing that happens to x, is it gets times by 2, and then it gets 4 taken away from it, and we end up with f of x. So to work backwards, we're just going to do the opposite every time. So f of x, going backwards, so instead of minus 4, we want a plus 4, and instead of times 2, we want to divide by 2, and we'll end up getting x again. And so that's our inverse function. So f minus 1 of x is going to be, so just follow the x along here, so it's just x, we add 4, and then we divide by 2. Okay. And then finally, we want f of x equals g of x, so that just means 2x minus 4 equals 3x plus 5. Okay, so let's just solve this. We want x's to be on one side, and I'll always take away the smaller number, so let's minus 2x from both sides. So we end up with minus 4 equals x plus 5, and then we want to take away the 5 from both sides, and we get that minus 9 is x, or x equals minus 9. Okay, great. Right, okay, so the diagram, we've got a solid shape, a hemisphere on top of a cylinder, lovely. We've got a very handy little square of formula, so we've got the volume of a sphere is 4 over 3 pi r cubed, and we've got the pressure equals force over area. So the solid shape is placed on a table. The solid exerts a force of 4 newtons on the table, and the pressure on the table is 100 newtons per meter squared. The height of the cylinder is 45 centimeters, and what is the total volume of the solid shape? Okay, a lot going on, but the first thing I've noticed is that they are giving us the newtons and the pressure, so that can give us the area of the bottom of this shape. So using this pressure thing then, this formula here, so pressure we know is 100, and that is force, which is 4 over the area, which we'll just write as A. Now we can times up by A, so let's just do this, let's times both sides by A, and then you're going to get 100A equals 4, and then we can divide by 100 both sides, so we get A is 4 over 100, or 1 over 25. Okay, and yeah, why don't we write that as a fraction? So 1 divided by 25 is just going to be 0.04, and we are on meters squared. Okay, now the next thing we're noticing is that this height is in centimeters and this is in meters. So I want to get them together on the same units, and I'm going to use centimeters just because I don't want to have to deal with decimals. So we know that 1 meter is 100 centimeters, but we're dealing with meters squared, so we square both sides, but 1 squared is 1, so 1 meter squared is 100 times 100, which is just 10,000 centimeters squared. So to get this into centimeters squared, I'm just going to times by 10,000. So 0.04 times 10,000 and that gives me 400 centimetres squared. Lovely. And that is the area of this circle here. That is 400. Okay, great. Okay, so we're doing alright. We want the volume of this shape. I'm going to use the fact that I know the area to figure out the radius. Okay, so area of the circle, it's in the front of the formula sheet. So area of a circle is pi times r squared, and that is 400. Okay, so to find out r, we want to divide by pi, so r squared is 400 over pi. And so ignore that equals, and then so r is going to be the square root of 400 over pi. Okay, so square root of 400 over pi. I'll tell you what, we'll leave it like that because we want our answer to be as accurate as possible. Okay, so finally we want the volume. So the first thing we want is the volume of the cylinder. So the volume of the cylinder is just going to be this area times the height. So let's call this C for cylinder, and we'll call that H for hemisphere. So the volume of the cylinder is just going to be 400 times 45. 400 times 45, which is 18,000 centimetres cubed. And then let's look at the volume for H. So let's just write that properly. Now we know that the volume of a sphere is 4 over 3 pi r cubed, but we want half of the sphere, so instead of 4 over 3, we want 2 over 3. And that's going to give the volume of a hemisphere. So let me grab a different colour again. What have I not used? Let's go for green. So volume of the hemisphere is going to be 2 over 3 pi times r cubed, but r is just 400 over pi cubed. Okay, so let's do all of this then. So 2 over 3 pi times 400 over pi cubed. Okay, and we end up with 3009, let's say, centimetres cubed. Okay, lovely. And so finally then, the total volume, let's write this down here. So the total volume is going to be 18,000 plus 3009, which is going to be 21,009 centimetres cubed. To the nearest whole number. Okay, so there was a lot going on there, but they've given us 6 marks, so well earned, I reckon. Okay, so the diagram shows a rectangle and all measurements are in centimetres. So we've got the top side being 2x plus 7 and we've got the height being x plus 3. And we want to show that the area of the rectangle is less than 45. Okay, so the area of a rectangle is just base times height. So this is just going to be 2x plus 7 times x plus 3 is less than 45. So let's expand these brackets. So 2x times x is 2x squared. 2x times 3 is 6x. 7 times x is 7x. Oops. 7 times x is 7x, and 7 times 3 is 21, and that is less than 45. A quick tidy up of the 6 and 7x is 2x squared plus 13x plus 21 is less than 45. And then I just want to take away the 45 from both sides. Let's just write that down. And I'm going to end up with 2x squared plus 13x minus 24 is less than 0 as required. Lovely. So again, just a little tip as we move forward. So this says show that this. Now the reason they do show that is because if you can't do that, you can still use that in part B. So don't worry if you don't get part A, because we can use that in part B. So we want to find a range of possible values of x. So let me just grab a different colour. So we want to solve basically 2x plus 7, x plus 3 is less than 45, but that is the same as solving 2x squared plus 13x minus 24 is less than 0. Okay, now there's lots of ways to solve this quadratic. So the way I factorise it is I will start off, because I've got a 2x here, I'll start off with 2x over 2. Then I will times these outside numbers, so 2 times minus 24 is minus 48. And then I'll use the same method that we use for quadratics when there's just an x squared at the front. So I want two numbers, the times to make minus 48 and add to make 13. And that to me looks to be 16 and minus 3. So that's going to be 2x plus 16 and 2x minus 3. And then I can factorise, well, I can simplify this 2 with this one. So that's going to become dividing by 2x plus 8. So we're ending up with x plus 8, 2x minus 3 is less than 0. Okay, so now we've got this, we've got two options then. We're saying that these two things, x plus 8 and 2x minus 3, are timesing together to be less than 0. Now two numbers will only give you a negative number if one of them is positive and one of them is negative. So let's just have a little think about that for now. Now x plus 8, if that is negative, that means that x has got to be less than minus 8. And if we look at our rectangle, if x is less than minus 8, then that x plus 3 is going to be negative, and that can't be right because you can't get a negative length. So this is what's making me think, let me write this down in a different colour. So this makes me think that x plus 8 is positive, so x is more than minus 8, and it's making me think that 2x minus 3 is negative, so 2x is less than 3, and x is less than 3 over 2, or 1.5. Okay, so we've got our answer now, that x is between minus 8 and 1.5. But again, let's look back at our circle. It can't be minus 8. The biggest this can be, this has got to be more than 0, so x has got to be more than minus 3. Because minus 3 plus 3 is 0, so this has got to be more than minus 3. So our actual final answer is going to be minus 3 is less than x is less than 1.5. That's our answer. Okay. Okay, so sketch the graph of y equals 2 sine x for angles x between 0 and 360. Well, the first thing I'll do is I'll draw y equals sine x, just so we see what that looks like. So y is sine of x. Now it starts off at 0, and the highest or lowest it can get to is 1 and minus 1. Okay, so it starts at 0, at 90 it reaches its peak, 1, it goes down to 0 for 180, then it reaches its trough for 270, and then back to 0. So it's a bit wobbly, but that's my sine of x. Now we want y equals 2 sine x. So that just means, so let's just write that in a different colour, 2 sine of x. That just means these maximum and minimum points are going to be doubled. So that's going to be 2, and that's going to be minus 2. But the graph is going to, in essence, well, very similar, but it's just going to be stretched upwards because we've got 2 sine x instead of x. Okay, so that blue one is the answer. Okay. Number 18 then, so the graph of y equals f of x is shown below. The coordinates of the maximum point of the curve are -2 and 1, and we want to write down the coordinates of the turning point. So the turning point is the maximum point of the curve with the equation y equals fx plus 3. Okay, so just a reminder then, if your number is outside of the f of x, then that only affects the y. So this is plus 3, so our x stays the same, -2, and we just have 3 to the y, so 1 plus 3 is 4. Now the second one, there are a couple of things happening. So remember, like we said before, if it's outside of the f of x, it only affects the y. So this time it's a minus, so instead of 1, it'll be -1. And the thing inside the f of x affects the x. But whatever affects the x is always kind of the opposite of what it looks like. So because it's x plus 2, we want to do the opposite. We want to take away 2 from the x. So because we were on -2 for x, we want to take away 2. So we're going to be left with -4, like that. Okay. Alright then, and then, oh, spoilers, I was having a go at this before. So let me just rub them out. So you already had a bit of a sneak preview of this one, but yeah, this is a pretty interesting one. There's a couple of circle theorems to think about here, so we'll have a look at these. But yeah, we'll end up with x over 2. Okay, so what have we got here? Okay, so we've got a circle. We've got an isosceles triangle in the circle that touches all the points of the circle. We've also got a tangent to the circle that touches the isosceles triangle at one of the vertices. And then we've got another line from the middle of the circle to the edge of the circle. Okay, so, and we want to figure out, our goal in the end is to figure out OED in terms of x. So that is this one here. That is our goal for the end. Okay. So there's a couple of things we want to just note before we start. So the first one is, the first circle theorem that we're going to use is the fact that a radius connected to a tangent is always at a 90-degree angle. So this angle here is 90 degrees. So that's the first thing we're going to use. So it says give reasons for each stage of your working. So the first thing I'm going to say is that OEA equals 90 degrees because a radius meeting a tangent to a circle are perpendicular. Yeah, so they're always 90 degrees. Okay, lovely. Alright, the second thing I want to notice is whenever you see a triangle and a tangent, so let me just draw a little mini version of this with things not kind of distracting. That's a circle. So if I've got a triangle like this and an angle like this, then let me just do it like this, then that. No, don't like that at all. Okay, let me redraw this. Let me do a better version of that. Okay, so the circle's slightly better already. Let's draw it like this, and we've got a tangent touching that triangle. Then this is the alternate segment theorem, so that means this angle here, so that's between the triangle edge and the tangent, is always equal to the opposite one on the triangle, so that is equal to that. And similarly, this angle here is going to be equal to that. Okay, and that's called the alternate segment theorem. Okay, so I think we're ready to go. So the first thing I'm going to actually use is the alternate segment theorem. So it tells us that AEC is x. So this is x. And so by the alternate segment theorem, this is going to be x. So I'll just write a little reason of that. So CDE equals x because of the alternate segment theorem. Okay, great. Okay, so we're starting to build something up. That is good. Now then, let's now use the fact that we've got an isosceles triangle. So we know that angles in a triangle add up to 180. We know that this angle up here, the red one, is x. So remaining, we're going to have 180 minus x. And that's going to be split between these two angles, isn't it? Yeah, because it's isosceles. Both of these are the same. So both of these are going to be 180 minus x divided by 2 because it's been halved. So that is that, and that is that as well. Okay. And then finally then, we're going to use the fact that, let me use another running out of colours here. Let's be boring and use a grey. So if this is 90 and this is x, then this bit here has got to be 90 minus x. Okay, so now I think I'm finally ready to write down what the angle is. So let's use blue again. So we want to write OED. So OED is going to be, well, to me, OED, so that's this green one here, yeah? Well, let's call it blue because we're doing it now. So OED is going to be CED. So CED take away CEO. Yeah, so it's going to be the whole angle of the triangle take away that CEO. Okay, so CED, so let's just redo this down here. So OED equals CED take away CEO. Okay, now CED is 180 minus x over 2. And we want to take away CEO, which was 90 minus x. Okay. And let's do that so we don't forget the minuses. So 180 over 2 is 90 minus x over 2. And then we want a minus 90, and then minus x is plus x. Okay. Now we have a 90 minus a 90, so they disappear, and we're left with minus x over 2 plus x. So this is the same as plus x, take away half of x, so you're just going to be left with x over 2. And that's your answer. Okay, so I hope that all made sense. And again, another juicy 5 marks. Alright, so number 20, is this the last one? Oh no, I've got 2 more. Okay, penultimate question then. So number 20, we want to work out the value of x, give your answer to 1 decimal place. Okay, so for this is screaming out the cos or the sine rule. And the way I think of it is the cos rule always looks like this kind of V that's got the angle there and then the 2 sides either side it. So that makes me think I want to use the cos rule. But for the cos rule, I would need to know this side as well. Okay, so my first goal is to figure out this blue side here, which I will just call, well, we've already got x, so let's call this y. Now for this, I'm going to want to use the sine rule. So I'm thinking about this triangle now, and I want to use, so let's just write it in highlighter if I can. Oh dear, sine. Okay, I'm kind of enjoying writing like that. Sine rule. Okay. So for the sine rule, I'll need to know the angle opposite y, but if I know that that's 53 and that's 71, I can add them up using my calculator. So 53 plus 71 is 124. Take that away from 180 and I end up with 56. So that there is 56. Then I can use the sine rule, which is in the front of our books. So we've got that y over sine of 56 equals, and then we'll use the other one that we know, which is 9 over sine of 71. And then we solve that, we times up by sine of 56, so y is 9 sine of 56 divided by sine of 71. And we'll just write that in our calculator. So 9 sine of 56 divided by sine of 71, and that is going to give us 7.891, and we'll leave it like that. So y is 7.891 centimetres. Okay, then I can use the cos rule, so let's grab a different colour for the cos rule. So the cos rule then is going to be, so a squared equals b squared plus c squared minus 2bc cos of a. Now our a is our x, so our a squared is going to be this squared because it's opposite. So this is going to be 7.891 squared is b squared, doesn't matter what b and c are, so b squared plus c squared minus 2bc times cos of a. Okay, so let's just work these out a little bit. So 7.891 squared. So I'll just work them out a bit just so you can see a bit more how this is looking. So this is 62.267881, let's say. It's going to be now 10 squared plus 13 squared is 269 minus 2 times 10 is 20 times 13 is 260 cos of a. Okay, so we've simplified that a bit. So now what I'm going to do is, let's, just so I get a nice positive number, we're going to add that to there, and then at the same time we're going to take away that to there. So we're going to end up with 260 cos of a is 269, take away this 62.267881, and that gives us 206.732119. Then we just divide by 260, so cos of a is 206.732, let's say, over 260, and so a is just going to be inverse cos of all this. Okay, which is going to be, so again, calculator shift cos, 206.732 divided by 260, and I think they wanted it to one decimal place, yeah, so that's going to be 37.3, and remember we've just worked out an angle, so give it the degrees symbol. Okay, so another chunky monkey, but we've managed to get 5 marks hopefully with that. Okay, final question then. So 50 people were asked which fruits they liked from apples, bananas and oranges. Okay, when it gives you this and it gives you a load of information, some people like bananas, some people like oranges, I like apples and bananas but I don't like oranges, you're going to need a Venn diagram. And we have got 3 things, so we want 3 circles in our Venn diagram. So a normal Venn diagram like that, and then you want to add a third one like that. So we've got apples, bananas and oranges, and we'll put this all in a square because there might be some that don't like any, and then they'll go outside of the circles. Okay, so let's see what we've got here. So the first thing is 11 people like all 3 fruits, so 11 is going to go in the middle. Okay, so let's cross off the ones that we've used. 33 people like apples. Okay, I'll come back to that in a minute because I don't know where that's going to be split between these kind of 3 empty bits here. So let's think about that in a minute. So 6 like apples and bananas, but not oranges. So 6 like apples and bananas, but not oranges. 15 like bananas and oranges. Well, if 11 are in the middle and we've got 15 that like bananas and oranges, then that has got to be 4 to make up the 15. So we've used these 2 now. 5 of the people do not like any of the fruits, so that will go outside. And then all 25 people who like oranges like at least one other fruit. So that actually means that this will be blank, this bit, because everyone who likes an orange likes something else. We've got 15 already from 11 and 4, so that means 10 must be in that box there. Okay. Then we can use this apples one, so 33 people like apples. We've got 6 plus 11 plus 10 is going to be 27, so to make up the 33, that must be 6. And then finally, we can use that there were 50 people overall. So altogether, well, we know apples is 27. We know all apples is 33, plus the 4 here is 37, plus the 5 is 42. So that means this must be 8. Okay. So finally then, so we've got all the things filled in. So now 2 of the 50 people are chosen at random. Work out the probability that they both like bananas. Well, how many people like bananas? So we've got 6 plus 11 plus 4 plus 8. So 6 plus 11 is 17, plus 4 is 21, plus 8 is 29. So 29 like bananas. So if 2 people are chosen at random, the first person is going to be 29 out of 50 probability. And then the second person is going to be 28 out of 49. Because there's one less banana and there's one less fruit altogether. So 29 out of 50 times 28 over 49. And that's going to give me 0.33, let's say, to 2 decimal places. Okay. Well, that's the end of the paper. So I hope you found that useful. I'll be doing paper 3 soon for foundation and higher. But yeah, good luck on June the 8th.